Okay, so short video to get you introduced into the code that is present here. So first, import the connection, change as whether you like. First function, get JSON files. It loads all the JSONs that were downloaded from the Atlas. It will be needed later. Then generate union is SQL and extract with clauses. This is doing what I told you last time. It gets the SQL generated by the library you showed me from the JSONs and extract the part that gets all of the concepts from the JSONs, including its descendants, and mapped the concepts. Then we have save fused events. This is a function that, as you can see, gets all drag exposure, visit occurrence, conditional occurrence, measurements, everything like this, and union it on so we have person ID, start date, event ID, and end date. So we have all of those with the same column names for later use. Then we have these concept IDs that creates from all of those mapped concepts the tables. I hope that you can create the table, as it would be far more neat to do it, I suppose, with these separate tables. It additionally get all of the data from those and return in order for debugging purposes, basically. Next function is fuse oncology concepts. It just gets basically the same as the function above, so it also gets all of the concepts, but all of the concepts combined from all of the cancer. Yes, so we have a cancer folder and we combine it to get the concepts. Then we have this get all concepts from the table that does just like this. Yes, this is a function, that helper function. Next we have the get filter concept set tables. So we are getting the from the schema of the database all of the tables that has the concept set name, so those has the concepts of the given file. Yes, so every JSON in the Atlas concept sets folder has its own table in the database as it was saved a moment ago. This just retrieves all of those names. It excludes 3 as those are special cases: myocardial infarction, old myocardial infarction, and other cardiovascular events. Why they are filtered out for, I will say you a bit later. Get myocardial infarction oncology concept, so it's just gets all of the concepts from myocardial infarction and from the cancer union table. So we have all of the oncologic concepts and all of the myocardial infarction concepts codes. One more time, because it was parsed from the SQL from the library that you have shown me, it has all mapped and descendants concepts also. Then we have this big table from all fused concepts, events, and things like that. We want to reduce it in order to speed things up. So first we select all of the person IDs that has some oncologic concept in them. We select all person IDs that has myocardial infarction. Then we change them into the set and get the common part. So we get intersection of those two sets. Those gives us all of the patient IDs that will have both myocardial infarction and oncologic condition. And this is the first thing that we do. So we create the first table, temporary table, and we get all of the person ID that is in this union of sets. Then we get all of the tables. We include those that were filtered out. so all of the tables with the concept sets. Then we concatenate them, get unique of them, so we have all of the concept IDs with all of the JSONs included, mapped and descendants, and we are getting filtering out all of the codes that are not present in this long list. This would greatly reduce the size of the table that we are working with. The next part is the get augmented microarray function. This is the important part. So here we are adding to this big table with the start date, event ID, end date, and person ID. We're adding 3 columns. So we're adding the column as the oncologic start date. So we get the first oncologic start date present generally in the table. We have the first in this person, I mean, first oncologic, the start date of first oncologic event. This should be like this. Then we have the start date of the first myocardial infarction event and the start date of the last myocardial infarction event. Sorry. So here we have min, max, and min. I would like you to look at this SQL a bit more if you can, because it's extremely slow, and it's very useful. It would be very useful for having this table, but I'm not sure how to speed it up. If you can look up this. Okay, then we are filtering with the dates. We cannot do it earlier because I will tell you in a moment. So first we get where the end date is before the oncologic start date plus interval of 2 years. So we want end after oncologic start date, so we want to have it between oncologic start date and 2 years later. Yes. And we also want only such patients that had some myocardial infarction before the oncologic start date. So this is a very easy way to get a definition of our cohort because of this augmented table. So this is quite important that these columns would be present. But one more time, if you would like, I would like you to see whether you can speed it up. Because in my computer it gets a couple hours and still working on this. Maybe it's because my laptop is crappy. I hope so. So next, then we are here in a moment. Yes. No. Okay. Good. Now and then we have just we are getting into the finishing touches. So create binary res. So we are creating the last function. So we are selecting. First, we are creating the column that is Mayo after onco. This table is true when we have some myocardial infarction after oncologic event. Yes. So basically, when we have the next myocardial infarction after we already had some oncologic event. This would be the first column. Then we add to this binary res table new columns, so it gets table name, so it passes through all of the concept set tables, so through all of these tables that were built based on the JSONs from the Atlas concept sets whole folder and subfolders. And then we are just checking whether we have these concepts present. Yes, when exists we select jeden, so we get augmented filtered. So this augmented means that we have these additional columns. Person ID needs to agree, and when we have this ID in those. If it's not present, when it does not exist, we have 0. So we have 1 if it is, 0 if not. And we add this column. Additionally, wait a moment. Yes. Okay. So we add column and then we update the values based on the patient ID, because each row has a unique patient ID. At least it should have. Additionally, we are selecting all of the information, all of the codes that were present in augmented filtered. Yes, so it means that all of the codes that were used in our cohort. In these concept tables, yes, this is the concept set tables, we have the concept ID and concept name. So this will enable me basically to debug whether the correct concepts were used. This is an additional check to filter out any big mishap with the definitions. Okay, and it's all. If it would work, as I hope it would, those steps would create us initial results. And I thank you very much. Please tell me whether you have any questions and any ideas of improvement.